This is a tutorial for boundary layer number 5. Assume that in the laminar boundary layer, the flow obeys the law of shear stress tau equal mu du dy, where mu is the viscosity, which lead to the profile of u minus u equal k delta minus y square, where capital U is the free stream velocity and small u is the velocity at the distance y above the plane and k is a constant. Determine the displacement thickness using the answer from above. Find the displacement thickness at the boundary condition, which is y equal to 0 and u is equal to 0. So from this equation, we found that the velocity profile is u minus u k delta over y square here. So what we need to do is actually we need to change this velocity profile into the common velocity profile that we could use in our common equations. So I think you already observed that in our equation, the common term is minus 1 minus u over u. So if we could here, we could say that we could get the 1 minus u over u from here by dividing the terms with u, and then we get this one. And then the question asks us to find the value of delta star. So this is the equation of a displacement thickness. We have term of 1 minus u over u here. So we substitute the terms here with this velocity profile, and then we do the integral process. Finally, we could get that delta star is equal k delta by the power of 3 over u3. And then we need to substitute with the boundary condition of y equal to 0 and u is equal to 0. So what we need to do is we just substitute the value of y equal to 0 and u to equal to 0 in the velocity profile. We get that u is equal k delta square. And then we substitute this value into this equation. So finally we could get delta star is equal to delta over 3.